We have a very interesting scenario here. Sally, who is a scientist, is trying to study turtles that are trying to colonize the many islands of Florida Keys. The Fun Island and the Great Island have no turtles at all. One year, let's say year zero, three turtles swim to both the islands. Okay? She returns in 1 year to see how the population grows in both the islands. However, when she returns, she adds another island to her list, which is the Quizzical Island. I like the name. She does not remember the number of turtles that entered the island last year, okay, but knows that there are currently 10 turtles on this island, which is the Quizzical Island. Let's say this is represented by Q. She gathers data for several years and counts how the number of turtles increase on each island over the years. The tables below summarize the information for the three islands. Which turtle population will eventually exceed all the other populations in the long run? Please pause the video and read the question again if you want. Please absorb all the information. So we've got three tables that we need to evaluate. Let's have a look at these tables separately. So these are the tables we are looking at. Let's start with the Fun Island. So in year zero, the number of turtles are 3. In the first year, we have 5. Then in the second year, we have 7. Then in the third year, the outcome is 9, 11, and 13. So you can easily come up with an outcome that is every year the number of turtles are increasing by +2. See, every year this is the constant that we are looking at. And whenever you have a constant increasing factor or decreasing factor, it means that it is basically a linear equation that we are looking at, in which our gradient is +2 and our y-intercept is basically the initial starting point, which is 3. So you can say that Fun Island is following a linear pattern with an equation 2x plus 3. Now I assume that you should be able to form simple basic equations. Let's have a look at the second scenario. In year 0, Great Island has 3 turtles. In year 1, Great Island has 6 turtles, then 12, 24, 48, 96. Can you identify the pattern? What's happening here? How did you get 6 from 3? So 3 multiplied by 2 is 6. 6 multiplied by 2 is 12. 12 multiplied by 2 is 24. So now we are multiplying turtles. So whenever you have a multiple, you know which equation you are looking at. Now this number is being multiplied by 2 to get the next year's number of turtles. So this is basically an exponential function. Whenever you have a multiple as a constant, you're looking at an exponential function. And I'm assuming you can now form the equation, which is y equals ab raised to power x. A is our initial count, which is this, and b is our growth factor. This is exponential growth, which is 2 here, and we have our exponent x, which is the number of years. This is an exponential growth function we are looking at. Now let's have a look at the last scenario, which is the Quizzical Island. In year 1, we have 10 turtles. In year 2, we have 40 turtles. Then in year 3, we've got 90. Then in year 4, we've got 160 and then 250. This looks a little interesting and confusing as well. I think that's why it's called Quizzical Island. But if you examine closely, you will see the outcome is basically the year squared multiplied by 10. How did we get 10? It is basically 1 squared, that is the year, multiplied by this constant 10, and you get 10. How do you get 40? You square this number, the year, that is 2 squared multiplied by 10, you get 40. Similarly, if you square 3 and then multiply by 10, you will get this number, the output, that is 90. Similarly, you square 4, multiply by 10, you will get 160. Now you can easily identify the pattern that Quizzical Island is following a quadratic growth. And the equation that we're looking at is y equals ax squared plus bx plus c, which is very easy to identify from these numbers. 10 is the constant here, and this is basically x squared. This is your equation. In this scenario, B and C are 0 and your final equation is this 10x squared. Now, before I move on to the graphs, there's one very important question that you must ask. How can we identify these various functions? And the answers are, whenever you have a common difference, you're looking at a linear function. Please remember this. Like in this scenario, the common difference was plus 2. If you add or subtract a common value, that is linear function. Second is common ratio. If you have a common ratio or a common multiple, you are looking at an exponential function. Like in this scenario, our common ratio, common multiple was 2. Lastly, how do you identify a quadratic equation? The first hint is to identify the difference of differences. This gets a little tricky, but if you identify this, you are done. Difference of differences. What does that mean? I have drawn a table for you. Let me show you that. Look at this. So what you do is you first take the difference of these values. We have this value. So the first difference is 40 minus 10, that is 30. Then you have 90 minus 40, that is 50. Then you have 160 minus 90, you have 70. Then you have 250 minus 160, that is 90. So this is your first difference. Then you take the difference of these numbers again. That is basically the difference of differences, or you can say the second difference. So if you subtract 30 from 50, you will get 20. If you subtract 50 from 70, you will get 20 again. If you subtract 90 from 70, you will get 20 again. So in a quadratic function, the difference of differences is a constant, which is the second difference. This is how the graphs of all these islands compare with each other. This is the fun island, which is a straight line. Then we have the great island, which is exponential. Then we have the quizzical island, which is a quadratic equation. So which turtle population will eventually exceed all the other populations in the long run? Initially, you might say that it's the quizzical island because it is quadratic. But please remember that in the long run, there is no match to this function. The exponential will exceed all other functions because there is no limit to this exponent. However, when you talk about a quadratic equation, you have y equals ax square plus bx plus c. The exponent is locked at 2. And when you talk about a linear function, y equals mx plus b, it is literally a sad function when you compare all of them. So to sum up, the exponential function will always show the massive increase. If you compare all these functions, this will easily beat all other functions. Exponential will be greater than quadratic, which will be greater than linear. This is what you need to remember. Now that you're familiar with the three types of functions, let's evaluate some examples and questions. If the initial population of rats was 20 and grew to 25 after the second year, which of the following functions best models the population of rats P with respect to the number of years T if the population growth of rats is considered to be exponential? We are already told that the function is exponential, so we are looking at this equation, y equals a into b whole raised to power x. And we already know that the initial count is 20. Now, what's the growth factor? What is basically b? So with the exponential growth, we always need to calculate the percent increase, which turns out to be, remember what the formula of percentage increase? You have the final value minus your initial value over your original value, which is 20, on which the increase is taking place into 100%. This comes out to be 25%. You need to convert it into decimal, which is 0.25. So the rate of increase will finally become 1.25. Please be very careful with this. If I asked you to calculate the increase, you take 0.25 of 20, you take 0.25 of 20, which comes out to be 5. Then you add this number to the initial number to get to our next year's count, let's say, which is 25. So please be very careful with this. So our final equation would look something like this. Y equals 20 into 1.25 raised to power t. This is our final answer, which is option choice B. Next question. Albert has a large book collection. He decides to trade in two of his used books for one new book each month at a local bookstore. Okay, two of his used books for one new book each month at a local bookstore. Which of the following best describes the relationship between time in months and the total number of books in Albert's collection? Increasing linear, decreasing linear, exponential growth, and exponential decay. Please pause the video and try to come up with a relationship yourself. So if you analyze each month what is happening, he's trading two of his books for one new book. So he's losing one book every month. So each month, if I have to write the relationship, each month Albert basically loses one book. Albert loses one book. This is your relationship. So this is a constant here. And whenever you have a constant increase or decrease, you are looking at a linear relationship. And because it's a decrease, we are looking at option choice B, decreasing linear. I hope you understand. Let's evaluate this interesting question. A minor league hockey team has been collecting ticket sales data over the past year. At a current price of $25 per ticket, an average of 4,000 seats are purchased. Okay. They predict that for each $1 increase in ticket price, 100 fewer tickets will be sold. So if they increase the price by $1, they will sell 100 fewer tickets. Which of the following functions best models the amount of money that the hockey teams expect to collect from the ticket sales Y based on a $X increase in ticket price? Very interesting. Please pause the video and read the question again if you want. So the money collected is basically very simple. You have the ticket price and you multiply this by the number of tickets sold. Very simple. Which in this scenario is, if you keep the price at 25, you will sell 4,000 seats. You will have your money generated, whatever the answer is. If you want me to calculate, let me do that for you. Just hold on, let me grab the calculator. So the answer is basically 25 into 4,000, which is 100,000. That's a good amount. Okay. However, they want to increase the ticket price by X dollars. So over here, you will have 25 plus X. Now, if you increase the price by X dollars, how many tickets will you sell? This is where we need to apply our proportion. Let's say on one hand, we have the dollars and on the other hand, we have the tickets sold. So if you increase the price by $1, you will sell 100 fewer tickets. So if you increase the price by X dollars, you cross multiply 100X less tickets. So over here, you will have 25 plus X into 4,000 minus this number 100X. So this is the profit, the money that will be generated if you increase the ticket price by X. So we are basically looking at, this is X, 100X. We are looking at option choice A, 25 plus X into 4,000 minus 100X. It's a quadratic function.